guys, Mrs. Traper here. Today we're going to continue talking about proofs. Our learning target is that you be able to communicate logical arguments that proves rectangles, parallelograms, as well as other shapes are congruent. And then our sex class criteria is you'll be able to define and identify quadrilaterals. Let's jump in. We're going to do 3 proofs today. The first one actually has some triangles in it. It says given C is the midpoint of AE and that AB is parallel to DE, prove that BC is congruent to DC. So what I like to do in my proof is I like to try to show what I want to prove first. So I am trying to prove this marking, and I think that if I can prove the 2 triangles are congruent, then I can say that those 2 sides are congruent because congruent parts of congruent triangles are congruent. So with that being said, let me kind of work backwards. How could I show these 2 triangles are congruent? Well, I know that I have a set of vertical angles, and I know that this midpoint business here would mean that these sides are equal. I'm really close to angle side angle. If I could prove that angle DEC is congruent to angle BAC, then I could say angle side angle. And I think that'll work because they are alternate interior angles. So I think we've got our game plan. Let me erase my markings and kind of start fresh. I always want to start with what I'm given, and that was the business about the midpoint. So that midpoint C is showing that these 2 markings can be put in. So I can say that AC is congruent. Well, that looked kind of weird. Let me fix it. AC is congruent to CE, and that was the definition of the midpoint. And I'm going to put my statements on one side, reason on the other. So there's my first bit. My next part that I can do, again, I'm going to try to do angle side angle. I can do this angle next. I'm going to do the reflexive angle we're given here, which is that angle ACB is congruent to angle DCE, and that is the vertical angle. Alright, so I've got a side, I've got an angle. Let's show our other side, or our other angle. We said we were going to use angle BAC. And, okay, so BAC and angle, this one, DEC. So those are alternate interior angles. So I'm going to put that. Actually, to be proper, what I should do first is say that those 2 lines were parallel. So actually, let me, I'm going to rewrite this here. I need to add a step above this. And it's actually kind of good to see this in action because I missed a step, so I need to go back and put it in. Because I'm going to say that I have alternate interior angles in that next step, I need to first have said in my proof that I had parallel lines. So it was something given to us, but I still need to write it in my proof. So I'm going to write in that AB is parallel to DE, and it was given. So I need to have that in my proof, actually, before I say alternate interior angles, so that my order makes sense. At this point, I have my 2 angles and my side. I can say the 2 triangles are congruent we used angle side angle congruency. So we just have to name the triangles. I'm going to name mine CAB. So triangle CAB. And so I went 1 mark, 1 mark, 2 mark, 1 mark, 1 mark, 2 mark. So I'll have to say CED. CED. So there we go. We have our 2 triangles are congruent, and since they're congruent, BC must be congruent to DC because congruent parts of congruent triangles are congruent. And let me go back and fix my markings. I always kind of forget to do these over top of the lines. There should be lines. So let me do that, and there, I cleaned it up, and I think we're done. Let's do the next one. Alright, here's my next one. It says, given rectangle ABCD, prove that diagonals AC and BD are congruent. So AC is this diagonal all the way across, and BD is this one here. I think I want to draw these 2 triangles separately, so I can kind of see them. They're layered on top of each other. So I'm actually gonna unpack them. So this is triangle. Let me match up letters. DAC. And this is triangle DBC. So now I can kind of see them separately. Let me fill in what was already there. So like these are right angles, for example. DC is congruent to itself, so I'm going to put that in. AD is congruent to BC because it's a rectangle. And we are trying to prove that AC, we're trying to prove that AC is congruent to BD. So here's, I think, my game plan, since what's red is what I want to prove, is I think I can do side angle side with the congruency, and then I can say, well, those two sides must have been congruent because congruent parts of congruent triangles are congruent. So let's do that. Let's jump in. I could do this in really any order. I'm going to go like side, then angle, then side. So I'm going to start with my ones with double marks. So AD and BC. So I'm going to say AD is congruent to BC. And my reason for that is that it was given to me, it's a rectangle, and this is the definition of a rectangle. Part of the definition of a rectangle is it has opposite congruent sides. So I can put that in. And then DC is congruent to DC. That is because of the reflexive property. All right, next I have these two right angles, so I can say angle ADC is congruent to angle BCD. And those are congruent because they're both right angles. So right angles are congruent to themselves. I'm just going to put RT for right. All right, at this point I have side angle side set up, so I can say my triangles are congruent by side angle side. I'll say triangle ADC. Oops, I put a D first for no reason. Triangle ADC is congruent to triangle BCD. Now that we have proven that they are congruent, I can now say that AC is congruent to BD because congruent parts of congruent triangles are congruent. And I think I'm done. We have one more. It says, given isosceles trapezoid EFGH, prove that EH is congruent to FG. Now, this says it was given to us that it's an isosceles trapezoid. And really this one's going to be kind of quick because isosceles trapezoids are ones where there are two base angles that are congruent and two legs, we can call them, that are congruent as well. So pretty simply, I'm going to jump in and say EH is congruent to FG because that is the definition of an isosceles trapezoid. And I can kind of be done just like that. All right, those are our proofs for today, guys. Sometimes they're nice, short, and sweet, and other times there's a lot going on, like the first two. I will see you next time when we do proofs, day 3, and then we'll wrap these proofs up. Bye, guys.